So let's take a look at what happens if we are given some of the roots and you have to figure out the polynomial. In this case, we're working with polynomials with real coefficients. By fundamental theorem of algebra, we know that if the polynomial has degree 3, that it is going to have 3 complex zeros. We also know that since the polynomial has real coefficients and 2 minus I is one of the roots, then its complex conjugate 2 plus I must also be a 0. So right away we know that f of x is going to equal x minus 4, and then x minus 2 minus I, and also x minus 2 plus I. The 2 plus I because we know that we have real coefficients. To multiply this out, we're going to have to rewrite it. So let's take a look at, this would be x plus 4, this would be x minus 2 plus I, and the second one will be x minus 2 minus I. Again, we want polynomial with real coefficients, so we do not want any of the I terms left. So let's just multiply this out. I'll show you an easy way to multiply this out. You can see how x minus 2 and x minus 2 are the same term in both these factors. The only difference is plus I minus I. So this is almost like a plus b and a minus b. So it'll be a squared minus b squared. So this would be x minus 2 squared. The middle term will drop out and you'll end up with minus I squared. And then finish it off. So pause the video here and finish it off, and then we'll check it. So assuming you've come back and multiplied it out, we know that x minus 2 bracket squared will give you x squared minus 4x plus 4. I squared is negative 1, so that'll make it a plus 1. So we have this polynomial. Now multiply term by term and see what we got. And you should end up with x times x squared is x cubed. We have x times negative 4x is negative 4x squared. X times 5 is 5x. 4 times x squared is 4x squared. 4 times negative 4x is negative 16x. 4 times 5 is 20. Negative 4x squared and 4x squared will cancel each other out, add up to 0 basically. 5x minus 16x will give you negative 11x, and then a plus 20. So that's your final answer.